Need of axle counter. Though DC track circuit is oldest method of train detection and is simple, it has certain limitations such as dependence on wooden or concrete sleepers, insulation rail joints and vulnerability for leakage on the tracks. In these aspects, axle counters score over track circuits. Advantages of axle counters: no dependence on wooden or concrete sleepers and insulation rail joints except for small length track circuit for trolley suppression. Enables train detection even at places like iron girder bridges, tunnels, tracks having leakage problems. One axle counter system can serve up to 20 kilometers long section. Brief description. Axle counter is a method of train detection. It comprises of an electronic system which senses and counts wheels passing at either end of a section of track under monitoring and decides whether the set track section is clear or occupied. This decision is passed on to other signaling circuits in interlocking. Axle counters shall conform to IRS specification S42 unless otherwise approved. Working principle. Axle counter consists of a set of track devices mounted on the rails, one at entry end and at one or more number of exits of the required track portion of track. This portion of track is known as track section. The places of monitoring having track devices are known as detection points DP or D. To determine the direction of train movement, each detection point has two sets of transmitter and receiver coils. Each set with a transmitter and receiver is known as channel. Adjacent channels at each detection point are separated from each other by 165 mm to 185 mm. Ideal is 175 mm. A transmitter coil is fed with an alternating current which generates alternating electromagnetic flux, and associated receiver coil gets induced EMF through flux linkages. However, these flux lines get interrupted when a wheel passes between transmitter and receiver coils, which results in reduction in amplitude and also change of phase in receiver coils induced voltage. These changes in amplitude and phase in receiver voltages are used for wheel sensing and are processed by electronic circuits for counting and tallying and deciding the status of section. Of axle counters. Type of axle counter as per number of detection points. These are 1D, 2D, 3D and 4D. D stands for detection point. 1D. Only one detection unit with two channels, 4 inductors. Normally used at berthing portion of termination station. Long sidings with dead end. 2D. 2 detection units with 4 channels, 8 inductors. Normally used at berthing portions, long sidings with entry and exit ends. Block sections. 3D. 3 detection units with 6 channels, 12 inductors. Normally used at point zone area. 4D. 4 detection units with 8 channels, 16 inductors. Normally used at more than one point and crossing area. Axle counters are manufactured under 2 broad categories: analog axle counters and digital axle counters. Analog axle counters. These mainly employ electronic hardware for various functions, logics and communications. Typically, this type uses only one frequency of 5 kHz for both the transmitter coils of each detection point. Types of analog axle counters. Indian Railways introduced analog axle counters of SEL and Siemens makes in 1970. Based on SEL design, two variants of axle counters were developed. They are single entry or exit ankle counters for straight portions, 2D type, developed by IIT of Delhi in 1978. These are known as RDSO Mark I axle counters. Multi-entry or exit ankle counters for point zones, 3D or 4D type, developed by IIT of Delhi in 1986. These are known as RDSO Mark II axle counters. Universal axle counters were developed by RDSO and IIT of Delhi in 1996 as one model to serve for 2D or 3D or 4D requirements with change in jumpering and number of cards. Among analog axle counters, universal axle counters are predominant in Indian Railways. Track section. Each analog axle counter can be used in lieu of only one track circuit known as track section. To use in a station or auto section, large number of analog axle counters are required, which is costly, occupies space and unwieldy for maintenance. To overcome this limitation, digital communication-based digital axle counters are being inducted since 2003 in Indian Railways. These can be used for more than one track section. Digital axle counters. These are software-driven and microprocessors or microcontrollers based. They use digital technology for signal processing, counting, and for communication from one to another. Typically, this type uses two separate frequencies of more than 20 kHz, one for each transmitter coil at each detection point. Types of digital axle counters. As of February 2011, following makes are in usage in Indian Railways. Single section digital axle counters, SSDAC. CEL, Alcatel, Eldine, GG Tronics, General Electricals, GE. Multi-section digital axle counters, MSDAC. Alcatel, Eldine. Siemens. Trolley suppression method. Need. Push trolleys are used for day-to-day inspections along the track. These are of lightweight and can be lifted off the track whenever needed. Similar to train wheels, push trolley wheels will also cause wheel counts when they pass over detection points. After such in-counts, if these trolleys are removed from the track without passing through the exit detection point, axle counter will show occupation even though trolley is physically off the track. To overcome this problem, an arrangement is required to suppress such wheel counts. This is known as trolley suppression, for which two methods are in use. Method 1. In amplitude modulation type of axle counters, a small track circuit of 26 meters to 65 meters as per speed is used, in which track transducers are placed and wheels are counted only if track relay is de-energized, which happens for a normal train. As push trolleys are insulated, they do not cause de-energization of track relay, so wheel dips caused by trolley wheels are ignored for counting. Note: the length of trolley suppression track circuit shall be of adequate and detector shall be placed at a suitable distance from insulation rail joint, so as to allow track repeater relay in the relay room to de-energize before the first wheel comes over track devices, or else certain wheels will be missed from counting. Method 2. As push trolley wheels are of smaller section, they generate less phase deviation compared to a normal train wheel. This difference is used to discriminate a trolley wheel from a normal train wheel. This method is adopted in digital axle counters of phase modulation type. Resetting. As axle counters are electronic devices having inductors on the track and connected to cables, they are susceptible to failure due to ambient electrostatic or electromagnetic disturbances caused by lightning or traction current surges or movement of other electromagnetic devices over them or interference by any other electromagnetic source. Such disturbances are temporary, random in nature and difficult to ascertain but are estimated to cause about 50% of axle counter failures. Such failures can be resolved by resetting, which is a facility given to the user, that is, operating staff. Different types of resets are used as per need. Direct hard reset. It will directly reset the axle counter to show clear indication without any verification. It shall not be provided as it is unsafe. Conditional hard reset. In conditional hard reset, cooperation between two persons is required. One for physical verification of non-occupation of concerned track section and confirming the same by turning the rotary knob on line verification box provided near the site, and another person for operating reset button on the concerned box. The axle counter will show clear after the conditional hard reset. Conditional hard reset is used in points zone, loop lines and sidings. Preparatory reset. In preparatory reset, after initiating reset, axle counters continue to show occupation, that is, concerned signals continue to show on aspect until a fresh count of in and out count of axles is taken and they tally with each other for one pilot train movement in the section. If they tally, then reset of axle counter takes place for restoring normal working, or else failure continues. This tallying of in and out counts is known as balance of counts. Preparatory reset is used in main line of station, intermediate block working, block proving by axle counters and auto sections. Note: in some railways, a modified procedure for allowing a first pilot train on signal without completion of resetting of axle counter is in use in sections with dense traffic. This requires manual verification and confirmation with staff on other side that there is no vehicle in the concerned section. Fresh in and out count is taken for this pilot train. If counts tally, then resetting of axle counter takes place, or else signals cannot be taken off for a second train. Maintenance staff have to attend to rectify the axle counter. In auto sections, preparatory reset is applied only after ensuring that entire auto section from one station to next station is clear of trains. Preparatory reset with acknowledgement also exists, in which operating staff's fresh confirmation after count balance is required for resetting. Supervisory reset. In sections having two axle counters for same track section, a healthy axle counter is used to reset the failed axle counter automatically. In auto sections using single section digital axle counters, one additional set of axle counters is used for exclusive use of auto resetting in conjunction with healthy track sections on either side of failed section. In auto sections using multi-section digital axle counters, a supervisory track section is separately defined and used for exclusive use of auto resetting of failed track section in conjunction with healthy track sections on either side of failed section.